myself Padmanabhan. I am a structural engineer and also a contractor, a blooming contractor. As a structural engineer, I have got an experience of more than 15 years of experience in structural engineering field, and more than 300 projects, more than 300 projects in and around Chennai. Throughout Tamil Nadu, we have constructed, and more engineering colleges in which it has been included engineering colleges and medical colleges, and also many commercial buildings, very popular commercial buildings and malls, residential buildings. So I have a vast experience in structural engineering in both steel and concrete. Now, both steel and concrete. Now, what is how we are going to? It is all about me. And now I have turned into a contractor. As a contractor, now I am constructing. I started construction 10 years back, and now we are running in my 12th project, including residential building and commercial building. I am applying the same structural concepts, and I have become a contractor because the passion towards civil engineering is running me. So, what is the next gen civil engineering? Today's topic, yesterday, ma'am gave me the next gen civil engineering driving smart growth and sustainable development. So, what is the next gen? What is next gen? Next gen is nothing but you civil engineers who are coming to who are studying civil engineering, and who is going to join in civil engineering is all our next gen civil engineers. And I usually say all the civil engineers are equivalent to doctors. Ma'am, I am audible right now? Hello? Hello, ma'am? I am audible, ma'am? Okay. All these civil engineers...
Yes, sir. You are audible, sir.
Yes. So mostly whenever I am also I was also working as a assistant professor in SRM University. When I was working as an assistant professor in SRM University, I was also a consultant for them for SRM University. So I used to tell the next gen civil engineers when I was training the next gen civil engineers. I used to tell them a civil engineer is equivalent to doctor. Why civil engineering is kept as civil engineering? Because we are to the people, for the people, and by the people only. We are also like what to say? We are also like how constitution runs. The same thing. It is also for civil engineering also. Whatever the things we are doing, we are going to do to the people only. For the environment, it is all depending upon the environment. Today, because civil engineering is called the mother of engineering. So in mother of engineering, from civil engineering only, most of all the branches are being developed. So all the branches are being basic is civil engineering only actually. So in civil engineering, we are having branches like rural, like structural engineering. Basically, I said structural, environmental. Structural is the basic thing for all the things. Structural, environmental, construction, surveying, geotechnical, water resource, construction management, seismic. It is all subdivided like that. We are having more disciplines, more than how today AI has been generated. Today we are having more than what AI is generated, because we are having such development and everything. And civil engineers play a most important role in the development of the country, because we have to today you can see enormous growth in development of transportation, due to which in transportation field, by developing the transportation field, today we can achieve, how we can achieve is we can achieve the timeline, because each and every city is getting developed. Before, if we see 10 years back, Chennai was the only tier 1 city in Tamil Nadu where where any other thing is not being there, because we are having only one tier 1 city. We don't have any other tier 1 city. We used to rush to Chennai. Everything has been being into the Chennai only. So we are all being rushed to Chennai. But today's generation, if you take everywhere, you can connect to Chennai within 1 hour because of transportation, which has been improved because of enormous improvement in civil engineering, enormous improvement in transportation field, like building the bridges, connecting from one place to another place, improving the vehicle speeds, improving the speed of the transportation, improving the railway networks, improving the metro rail station. You can see all the metro rail stations are being developed, by which the immediate fast transportation is being happening. If you take it from now on, the next gen civil engineers, if you take it, you are going to develop a very enormous world which you see in English movies like Avengers. They'll be traveling from one place to more than it. You will be thinking of in Dubai, in Saudi. They'll be traveling for 360 kilometers within 1 hour. It is the same thing which is happening in India also. We are also traveling like that only. From India, from Chennai to nowadays, it has been improved. We are getting improved in transportation also. So, and then building wise, if you take building wise, we are all step by step. The generation is getting developed. So, as the generation get developed, there is also a material generation being developed. There is also a material generation which we were doing the research before. We were having only, we used to do the concreting. Concrete technology is the most vast field in civil engineering, where we can see it is a very vast field today. In concrete technology, before 10 years, we used to do only we used to do a grade of M20. Today, the minimum grade of concrete for residential building itself, we are going for M30. We are going for design mix. We are asking for design mix. Everything has been improved because we are going for RMC. Ready mix has been came, and it has been into colloquial use. Nowadays, we are going for a strength of M200, geopolymer concrete, like various without cement, how we can prepare concrete, without curing, how we can prepare concrete. So we are preparing concrete, and we are self-sustainable, and we are not affecting the environment, and we are growing to ourselves, and we are getting improved day by day, because as we are also, as you can see the other generation, like AI, if you see in computer science, the AI is growing. Similarly, we are also growing with AI only, because today's we should not disturb the environment with the same, without disturbing the environment. We are also generating geopolymer concrete. The geopolymer concrete is a concrete in which we don't use cement itself. We will not use any cement, or we will not use any cement is not from totally a waste product, like ground granulated blast furnace slags. We are producing cement. We are producing a concrete which is giving a strength of more than M100, M200 without curing, without wasting this, because it is also environmental free concrete. And the next fields are in structural engineering. We are having we have already involved in AI generation today, as AI generation. Sir,
you want the only one thing?
Pardon, sir, I couldn't get you. Hello, sir. Yes. In structural engineering field is also today AI generated field. It has become an AI generated field. And in structural engineering field, we are seeing it is all being automated. The beams, columns, and the span. If you take the steel structures, it is all being generated from. If you take seismic factors, seismic resistance structures, it is all being AI generated, and it is all being generated with span to depth ratios, it is all been generated. But whatever the thing is being generated with AI, but we are also developing with our self-sustainability. We have to, as a civil engineer, we are also, there is a need of checking things as a human. We should not collide with the computers. Civil engineering is a thing which needs more human thinking, and which needs more manually seeing the things. That is the field called civil engineering, because we are being with people. We are not dealing with any machineries. We'll be dealing with people. We'll be dealing with dealing with different ranges of people from top to bottom. If you're doing with a multi-storied commercial buildings, if you are doing any commercial MNC jobs, you'll be dealing with a very, very high profile people, where the people will be very, you cannot see the same type of people in the next level. When you are going to build a residential building, sir, I have handled like that project, I have to put M100, same M100, I have to put, you have to deal with the people's. So that only, like starting my presentation, I said the civil engineering is a field for the people, by the people, and of the people. And in civil engineering, the first basic branch is building planning and construction. The next thing is surveying and leveling. The next branch is advanced construction technology, and then geotechnical engineering, then structural engineering, then water resource engineering is there, then transportation engineering is there, environmental engineering is there, town planning, irrigation and water resource, soil mechanics. It is also come under geotechnical engineering only. But when if we take the surveying and leveling, it is all interconnected.
Yes,
whatever the field.
Sir, can you change your slide is only in the first slide. Can you change the slides?
Yes, ma'am. My slide is not getting moved actually. If I move it from here. My slide is getting changed, ma'am.
It's getting changed, sir.
Thank you.
Yes.
Yeah. So these are all the branches of civil engineering, as I said now. In branches of civil engineering, what we see is building, planning, and construction. What we all know. Actually, whenever now I'll say the stages of how we'll be seeing the world by tomorrow. Ma'am, today all our first year students, ma'am, or they are all into civil engineering, ma'am. Hello, ma'am.
Mostly civil engineering students have joined, sir.
Yeah, okay, ma'am. Sure. Okay. Then they are all first year, ma'am. They are all second year.
Second, third, first years, as well as other people.
Fine, fine. Sure. Why I ask this question is because tomorrow civil engineers, what you are going to do in the field. So first, the basic thing for civil engineering is always planning. Planning is the basic tool for not only a civil engineering. It is also a basic tool for all the engineering fields and also for the basic life. If we are not doing any planning, the work will be affected. So that only the civil engineers are dealing with more people. So we need planning basically. Planning is nothing but it is not only putting the plan in papers, drawing the plan in papers, and locating the columns, locating the beams, it is not only up to the paperwork. It is also to the site work also. It includes to the site work also. When we are planning a site, when we are planning for a construction, when a client visits the site, visit our office for a construction work, what we will do basically is what are else is requirement. His requirement has to be planned first. After planning his requirement only, we'll be preparing a plan for him. What is a plan? Plan is nothing but architectural drawing, and after preparing the architectural drawing, it is called, the basic plan is called a schematic plan. After preparing a schematic plan, we'll be giving it to the, after architecture also nowadays, it has been in the architectural field. Architect will be preparing the schematic drawings and prepare all the schematic drawings and will be presenting it to the client. After presenting it to the client will be reviewing the drawing, what type of work it is needed and how it can be handled. So what are all the improvement to be needed to be put in the plan. So like those things, he'll be adding it. Then after adding those things, it will be coming to the architect back and he'll be preparing a working plan. After preparing a working plan only, it will be coming to the structural engineer. So the first architect plays a main role. He'll be preparing all the plans. Then after preparing all the plans, after receiving all the inputs from the client, after architecture, it will come to structure. When it comes to structure, we will be preparing, we'll give some inputs, like we have to place the columns, we have to place we have to place columns is all vertical members is called column and the horizontal members is called beam. Okay, we have to, as a civil engineer, we should use civil engineering terms only. So that only I'm saying we should not say it as pillars, we should not say it as what to say, we should not say beam as column, column as beam. Okay, all the civil engineers should, whenever they are entering into the field, they should speak technically. Or else today everyone is a civil engineer. Yeah, because you can see most of them will see how you are saying this in the pillar and we should not speak when you are going to the site. We should speak very legibly and very neatly. We should speak very technically as a civil engineer. Then only the work will be getting what to say, okay, this civil engineering, he is a civil engineer, he knows more than us. They'll be thinking, the client will be thinking, because today there is a world called YouTube. YouTube is providing you enormous thing today. So we can, okay, I am going out of the topic. Again, I'll come to that. Next, after preparing the architectural plan, we have to come to the structural engineering. Here plays the structural engineering role. In structural engineering, what you'll do is, you'll be preparing the column and beam layouts. After preparing the column and beam layouts, you have to prepare the column and beam layouts in such a way that your architectural plan should not be disturbed according to the client inputs. The client would have been asked, maybe he is not a civil engineer, he would have asked for a cantilever section, he would have asked for a balcony. It should not interrupt with any intersection of beam. It should not be interrupting with any intersection of columns. Like those structure, you should provide a very clean structure to them. For that only the structural engineer being appointed. What is the span? We can maximum span without knowing. Here you can some developers you can see in a recent time. Some developers in Mugaliwakam you can see building 5 years. Yeah, it is 10 years back. 10 years back in Mugaliwakam, a structure has been just literally collided in Mugaliwakam. Why? Because it has been designed by a structural engineer, very famous structural engineer, and then it has been executed in the site. At the site, the builder has told the builder is not a civil engineer, he is a businessman. When the builder is not a civil engineer, he has told in the site, I have to avoid some car parking. If I avoid some car parking, I will not get some lakhs. So lakhs of money. So he removed the column. So what happened is he has removed n number of columns. What happened is it is the columns, when you remove the n number of columns, the columns are legs of the buildings. When you remove the legs, how you can stand? We cannot stand. The same thing happened when he removed the column. They constructed up to G plus 10 floors. It is a G plus 10 story building. After it didn't resist to a livelihood also. It didn't resist to a livelihood also. It has failed due to its self-weight itself, because it cannot stand, because you have removed the leg. How we can stand without a leg? Like that only the structure has been false. So structural engineering plays a most vital role in civil engineering, because we have to plan accordingly how much span you are giving the column, how much span you are giving wherever the structural engineering is required. You have to apply, you have to check the loads, you have to provide maximum size of the column, and whatever the as per the analysis it has been provided, and it should be represented in the site. Okay, then comes after giving to the structural engineer, then all these drawing parts will be completed after giving to a structural engineer. After completing this structural drawing, in between architectural and structural, what they'll do is they'll do the surveying of the ground. What they'll say is it will be done before coming to the architecture, after meeting the architecture itself, they'll be doing the surveying of the ground. They'll be marking the boundaries of the ground, and they'll be what is the level of the ground is there, how it has been level. If you are going for bridge construction and all, you can see some people taking the total station dumpy level. Everyone will be standing, and they'll be taking the leveling staffs. You can see the person keeping the leveling staffs and taking the measurement what this guy is doing. When other departments see, they'll be thinking, oh, what these guys are doing with they are taking some photos. No, it is all we are measuring, we are surveying, we are taking the levels, we are taking the ups and downs, and what has to be cut and what has to be filled, and how it can be, where is the boundary of the plot. Everything is being done in this surveying and leveling. They'll again come to the architect, and then they'll be plotting the drawing, and then the structural engineering things will be going on. And also, while after completing the surveying and leveling, before the structural, after putting the structural layout also, in between there is a geotechnical engineering works has to be taken place. What is geotechnical engineering? Why I need a geotechnical engineering? I said before, all the columns are the legs of the building. Okay, we cannot stand without our legs. Like same thing, building cannot stand without a column. Today we are all constructing only framed structure. We are not constructing a load-bearing structure. In load-bearing structure, they will be constructing wherever the load is being transferred, they will be constructing the wall throughout the structure. It is all more than limit. Now we are all limited because the enormous thing has been used in before engineering, before limit state method was introduced. The enormous engineering, enormous material were used, which cannot be shaken by earthquake also. So that only you can see, for example, Central Railway Station tower building and Egmore Railway Station buildings, which are being built by British. Those things are all load-bearing structures. Their foundation will be enormous, and they are not built by limit state method. Now we are all limited. We are all limited to resources. We are all limited to we cannot use the it is all economic. The material is being resource limited. We are going for an alternate material. We are going for, before it was being construction, we'll be doing the construction with river sand. Now we are doing with M sand. So all the materials, we are going for alternate materials for we are being alternate materials for coarse aggregate, alternate material for fine aggregate. Like those things, we are going for an alternate things, and also we are limiting the things, so that only so huge research works are going on in civil engineering for alternate strength, for increasing the strength in concrete with alternate materials, for alternate like coarse aggregate, fine aggregate, everything they are changing. And also cement also, it includes cement also, an alternate for cement. As I said, in geopolymer concrete, it is also an alternate for cement. Like we are being limited, so it is called, so that only the scientists are named our method as called limit state method. And in that limit state method, we are going for framed structure only. In framed structure, the columns are more important because columns are the leg of the building. And while designing the columns are leg of the building, when you have the foot, okay, when you stamp on some loose soil, what will happen? Your soil will get, your foot will get, for your weight, your foot will get inserted into the soil. So like the same thing only, the soil is also a bearing capacity. They'll say it is called a bearing capacity. In that bearing capacity, what they'll do is, with the help of that bearing capacity, they'll be finding the excuse me. They'll be finding the, in geotechnical engineering, they'll be finding the below what are all the bearing capacity of the soil. You can see in metro railway now. You can see in the metro railway, in some places they'll be drilling the piles and they'll be bringing the structure in the elevated corridor. In some places they'll be dredging. They'll be using the tunnel boring machine and they'll be dredging. And these are all the conditions, because where the geotechnical engineering plays a major role, where it has to be elevated, how the structure, how the soil condition is there. So if there is some rocky strata and some heavy soil condition, they'll be going for tunneling, tunnel boring, and they'll be taking the transportation. And in some conditions, there'll be more there'll be a crowded place also. But geotechnical engineering plays a vital role in selecting the types of foundations. It plays a major role. There are different types of foundations like shallow foundation, deep foundation. You'll be studying all these things in the forthcoming year. And these foundations, what type of foundation we should go for, which type of building is being decided by the geotechnical engineering only. What is below the ground, how much the soil can bear, on which our building loads can be bared. So deciding such things is called geotechnical engineering. Then it comes the, after geotechnical engineering, you'll be having the after geotechnical engineering, you'll be having the again you'll be coming to structural engineering. You'll be designing all the frames and you'll be constructing the building. What is okay, sir? It is all okay. First four things you have said: surveying and leveling, building planning and construction, advanced construction, structural engineering. Okay, geotechnical engineering also okay. What is water resource engineering playing? What is water resource engineering roles in our department? If you come and ask, and the water resource engineering is dams, reservoirs, channels, water channels, and whatever the tank structures you construct. You construct public tank structures like metro water, which comes to your home daily. You are pumping the metro water station from metro water station from where you are collecting the water to entire how the water resource is being used for the entire city. How the Chennai city is getting water without stagnation. For those things, water resource management is very important. So water resource management is also a major role which is played. How we can maintain the, now Porur lake is there, how many lakes are there, how the water resource can be improved, how the groundwater level can be improved, how from where the groundwater level is being generated, where you can put the bore, and how the water level is there in the bore, which will be telling in the water resource engineering. Then transportation engineering, I already said, the transportation engineering is nothing but how roads, rails, bridges, everything comes under transportation engineering. As I initially said, we need connectivity. Without connectivity, because today there is an enormous connectivity which has been playing a major role in the development. Because without connectivity, before we need to come when we need to go from Annanagar to Avadi, we have to use there is no connectivity. We have to, before 10 years back, we used to study in colleges when we used to come from Annanagar to Avadi. It will take hours of time. Now the roads are being now roads are more feasible. Public transport are more feasible, and we are reaching in time. It is the improvement. It is the transportation engineering. Now tunnels, bridges, and all those things, how you link from one place to another, it is all comes under transportation engineering. Then, and transportation engineering, it also covers the metro rail, and it also covers the ordinary rails, and now in future generation it will be bullet rails, all those things, and the hyperloop, it will all be coming in our transportation engineering only. Environmental engineering is nothing but how you place the environment, because as I said, the civil engineer is the by the people, for the people, of the people, is the entire thing. We have to protect the environment, we have to take from the environment, we have to give it to the environment. Environmental engineering is how in a residential building you will be having all the sewage treatment plants, you will be having all the wastewater collection pits, and you'll be treating it, and you'll be sending it, and how you should not contaminate the environment, so that we should also play a major role in not contaminating the environment, so that only environmental engineering plays a major role. You'll be studying all those, how we have to treat the used products, and how we have to treat the waste into feasible project, and it is called environmental engineering. Then town planning. Town planning is nothing but how we have to plan a town, because Chennai is a planned town, Bangalore is an unplanned town. As Chennai was planned by British, and again the same planning which has been continued, and it is been developed in the vast thing, and it has been developed in a good way, so that only we are getting sub drainage system, and subsoil drainage system, and groundwater. We are taking the pipes. We are having a proper planning system. Without planning, if you take Bangalore is a little bit unplanned city. They are facing very huge traffic conditions. So it is all the thing how you plan the town. It is all includes how you include the transportation engineering into a town planning, how a town should be developed, how what are all the requirement in town planning, how what type of town planning you are going to do, whether you are going to do with the industrial shipyard, whether you are going to arrange near the industrial shipyard. Those are the things which will be. And also irrigation engineering. Irrigation engineering is most irrigation engineering. We also do what type of crops, because it is all related to geotechnical. It is all coming under irrigation engineering, soil mechanics, foundation engineering, and it is all comes under geotechnical engineering only. What type of crops can be grown? We are also into agriculture. As a civil engineer, it is for the people. For the people, when you are also doing the agriculture. In agriculture, what type of soil it is, how what type of crop we can grow in which type of soil, and how the crops are being grown, how the water resource can be used for which type of crop, and how much drip irrigation, what type of irrigation it is required, whether it is like a drip irrigation or flooded irrigation, and all the methodological statement can be brought into irrigation engineering. We are also irrigation is a vast thing from civil engineering only. We are also doing irrigation now. We can see in foreign countries they will be doing drip irrigation. It is also being used in our country also. In our country also we do in a vast stage drip irrigation nowadays. We are not flooding the water. We are using drip irrigation for the crop which have been which needed drip irrigation. We are doing drip irrigation, and we are doing the drip irrigation. So it is all soil mechanics and foundation engineering. As I said, in geotechnical engineering, it is also the same mechanism which will be used. Remote sensing and geomatics it will be coming in. Remote sensing is nothing but you will be receiving the things from satellite. Remote sensing and geomatic is which all comes under surveying and leveling. So these are all the fields which we are being seen. Thank you, man. Thank you. Thank you for listening. Hello, ma'am.
Hello, sir.
Yes, ma'am. I completed.
Hello,
Yes, ma'am.
am I audible, sir?
Yeah, ma'am, you are audible. Yes.
Thank you so much, sir.
Yes.
Participants, a feedback link has been shared in the chat box. Kindly take your time to fill the box, fill the feedback form. And on behalf of the management of SA Engineering College and the Department of Civil Engineering, I thank the speaker, Mr. Padmanabhan, for his most thought-provoking speech on the need of civil engineering in day-to-day life. Thank you so much, sir, for your valuable time.
Thank you.
Participants, please make sure you're filling the feedback form. And thank you all for attending the session.
Can I leave the session? Hello, ma'am. Ma'am, can I leave the session?
Yes, sir. Yes, sir. We can leave this.
Yeah. Thank you, ma'am.